Hello, good morning to all the students. Okay, now not good morning and there's a good afternoon to all the students. Okay, so today the class should be the physics lesson. Okay, how many is on the line now? Please reply me. You can see me. You can listen me or not. Okay, we just see any student answer my question. Okay, we got 26 student now is watching. Hello, anybody here? Okay, can see me and also can listen me or not? Okay, Sarah. Okay, yes, sir. So how about the others? The others got follow class or not? Today our class is 11:45 until 12:45. Okay, today we need to go to the new topics. Okay, new topics. I think the lesson, the module I will give you later lah. So you just follow the first topic. Okay, the part 1. Okay, so the others, only Sarah here. The rest. Okay, you can answer me in the chat box. Okay, so we don't waste the time. So we straightforward to start our lesson. Okay, so we go through it. So lesson 4.3, there's a related with the also heat. Because this one topic should be the heat, but this one we call it as a specific latent heat. Okay, later we go to explain what is a latent heat, what's the difference between what we learned for 4.2, there's a specific heat capacity. Okay, so from here, go through the next page. Okay, first one, we're going to do some introduction. You can see this one, ice kacang. Okay, after a while, what changes to the ice kacang? So you find it that sure the ice will start to melt, is it? So when starting, you find it, oh, they're just like the ice mountain. After a while, so you find it, the mountain becomes slowly become go downwards, okay? So because this ice, they start to melt, is it? So from here, we go to answer, it will melt, okay, because they're absorbing the heat from the surroundings. Okay, if you keep inside the refrigerator, that means they keep freezing. They keep freezing, but you put outside, you find it outside, we got high temperature. They just like the room temperature. So the ice, they will absorb the heat. Okay, good morning, Celia. Sejarah test because late for 30 minutes to do it. So that means my lesson already is taken by the sejarah lesson, is it? What you mean about 30 minutes? Late for 30 minutes, so that means they will take my class for 30 minutes, is it? My class only 1 hour, so they want to take 30 minutes. Okay, never mind. I will continue for the lesson. So for the students that just later, they go to record back the video, but they need to do the Google Classroom and also Google Form later. So I continue to my lesson first. Okay, Celia, can you tell me who's the sejarah teacher? Okay, you just type the name there. Okay, so from here, because absorbing for the heat from the surrounding, so the ice they start to melt. Okay, another situation is steaming. Okay, I think normally, normally they do the steaming for the fish. They're not using the water go to steam the fish, they're using the gas. Okay, the gas should be the hot gas. Okay, because you go to cook, go to boil the water. When you just boil the water, they produce the gas. You see, that one, the gas is a high temperature gas. We didn't say there's a gas, we said there's a steam. Okay, so from here, a fish can be cooked by steaming in a steamer pot. So what changes to the water in the steamer pot when it just boils? So the water, they will change to the gas. There's a high temperature gas. So this one is what we need to learn about latent heat is changes the phrase. Change the phrase. So melt means from the solid become liquid. Okay, if I say about boiling is from the liquid, change become the gas. So latent heat is talking about changes phase. Okay, we never mention about temperature, only the phase changes. Okay, then the student asks, then where the temperature go? How come you provide the heat, then the temperature no changes? Okay, so this one is one of the question. We will answer it later. Okay, after you continue the lesson. Okay, now we go and see the element. I think the element every student also know about the three element state. There's a solid, liquid, and also the gas. Okay, let's see the diagram. First one, we know solid. Example for water lah. We take the water. Solid will become the ice. Okay, ice, you know the molecule. Solid molecule must be closer and also cannot move further, is it? That one we call solid molecule. Okay, how about the arrangement closer? After that, how about the attraction forces? Attraction forces sure become strong. Okay, stronger molecule bond in a solid, so that's why they cannot escape. Okay, number two should be the liquid. Okay, liquid just like the water. So now you find the molecule far a bit lah. They still can vibrate, go outside a bit, because now they become medium, not too strong, but you cannot lose. They still join by each other. So from here we just say the less strong molecule bond in the liquid. Okay, they start to vibrate a bit and also go further a bit, but they still cannot lift out. Okay, so we go to the last element state. There's a gas. Okay, gas, you can see the molecule now, they move randomly. Okay, they never join the bond each other. So this one we call it as a big bond. Okay, the warm bond become because between the gas molecule and move randomly. Okay, so this one is a arrangement of the molecule for the three situation for the elements. Okay, now we want to see about changes the phase of the metal. Okay, what situation that will changes the phase? Okay, need to go. The first one is a latent heat. Okay, we see what means of the latent heat. Okay, latent heat is a heat absorbed, or you say the heat release. Okay, because heat absorb and heat release. When you just boil, you absorb the heat. Okay, when you condensation, remember condensation, from the gas go back to liquid, that one is release the heat because you want cool down. Okay, one you want heat up, we say absorb heat. Okay, one you want cool down, we say release the heat. Okay, latent heat is a absorb and also you can say release the heat at constant temperature. That means the situation will never related with the temperature during the changes the phase. Okay, so you must remember when we just talking changes the phase, the temperature must be constant. Okay, later they got question why they will become constant. Okay, see chambers. Okay, we got melting. Melting, I think every student know. Okay, the ice left for 5 minutes, then melt already become water, is it? So this one, we call it latent heat absorb, because you absorb, is it? Okay, solidification means opposite. You solidify. From the liquid, you put inside the fridge, then they become ice. Okay, so liquid becomes solid. This one, we call it latent heat release. Okay, they release the heat, so they cool down. Okay, number three, we call it as a boiling. Boiling, that means you heat the water until boil 100 degrees Celsius. They become gas. So this one we call latent heat absorb. And the last phrase, there's a condensations. Condensation, that means you trap the gas. Then the gas change back become the liquid. We call condensations. So the one latent heat is a release. Okay, so you must remember all is a latent heat, but one is a absorb, another one should be the release. Okay, now we continue to see the diagram, the cycle. Okay, you can see the different phases when it just happened. Okay, first one is from the melting, from the solid, they go become the liquid. So this one we call latent heat absorbed. Okay, From the liquid, I want to boil, heat the water, keep heating, so they be boiling. So they keep boiling. Boiling also is a latent heat absorbed. So when you see the arrow just go up, that one is absorbed. Okay, so if I want to straightforward from the solid, become the gases also can. The process we call sublimations. Sublimation because the very high temperature, straightforward, they never convert to the liquid, they straightforward become the gas. So this one is normally we said it as a dry ice lah. Okay, they can straightforward to heat, then they produce the gases. Okay, so this one also latent heat absorbed. So when you see the arrow just come down, the arrow come down means they cool down. So this one is a latent heat release. The first one should be condensations. From the liquid to solid, we call it solidification. This one is a latent heat release. Okay, so now we just go through latent heat. Okay, we not yet go through specific, because specific we need to find out what is the mass of the object. Okay, we go through to the next part. Okay, you can see the vibration for the molecule. First part, the solid should be closer. Okay, when they become liquid, they far a bit. And when they just become the gas, there's a randomly to move it. Okay, so we go through to the next part. Okay, now the quantity of the heat that needed to change the state of the metal of an object, that depends on the mass. Sure depends on the mass. What? If the mass is bigger, so you need the heat should be more lah. Solidification same as a freezing. Yeah, correct. Okay, see that is the same meaning. Huh? Okay, so you want to change the metal. So you need to provide the heat, is it? When you just provide the heat, it must depend on the mass. Okay, mass different, the heat provided also must be different. Okay, so from here, we need to introduce specific latent heat. Okay, so when I just introduce one physical quantity, you must know what is the definitions. Okay, definition is amount of the heat required to change 1 kg object. Okay, we're talking about the mass without change in the temperature. So we're talking about the heat. You want to provide how many heat. Then after that, you need to depend the mass and also not related with the temperature. So that means the formula sure no temperature. Okay, sure no temperature. Only got mass and also the heat. Okay, so this one is what I want to introduce for the specific heat capacity. What is the definitions? Okay, so we continue to the next part. Okay, this one should be the formula. I want to show about the formula for the latent heat. Q equal ml. Okay, Q is a heat. Okay, now is what heat? We call it as a heat, latent heat also lah. We call it as a, we cannot call latent heat, we just say heat only, energy. Q is an energy. Okay, so from here, M stand for what? M is stand for the mass. Okay, Q is a heat absorbed. Okay, or you say heat release. Okay, for the situation, we got release, we got absorb, is it? Depend your phrase lah, changes phrase. Then after that, we got mass of the material. Then L is a specific latent heat. So when you see the latent heat, what's the unit? Joule per kilograms. Okay, joule per kilograms. So that means no temperature. So you no need to put data. Okay, degree Celsius, no. Okay, so from here, normally we want to find is a latent heat lah, specific latent heat, is it? So I show you the formula. If you want to find the L, so the L must be Q over the M. Okay, Q is the energy over the mass. So from here, the SI unit for the specific latent heat is a joule per kilograms. Okay, so this one, remember the definitions, remember the formula, and remember what is a SI unit. Okay, so from here, I want to continue to the next part. Okay, now we go through. Okay, melting. When you see the ice from the solid to become liquid. Okay, so this one we call it latent heat, is it? but they got the special name. We only not only call latent heat. You know this one latent heat is what? This one latent heat is absorbed. So if I say from the liquid becomes solid, that's the latent heat release, is it? So from here, I want to show the name for this part is what? This part we call specific latent heat of fusion. Okay, they got the name of fusion and you need to add. Okay, that's the fusions. So from here, the symbol, we just write LF. Okay, the F is a small f. Okay, if I say terbalik, from the liquid go to solid, we call what name? The name also same. Okay, specific latent heat of fusions. So if you scared you mistake, is it? So you add one more word behind. Solid to liquid, specific latent heat of fusion, then you say absorbed. Okay, if liquid go to solid, just like Siliang said, freezing, we call it as a specific latent heat of fusion released. Okay, you just add absorb and you add release. Okay, that one is a one. What is the differences? Okay, number two is boiling. Okay, boiling. From the liquid, you boil until it become the gas. Okay, you change the phrase, is it? So we call it as a specific latent heat of verbalizations. So LV. Liquid to gas is absorbed. From the gas go back to liquid, we call it released. So also same the name, specific latent heat of verbalizations. Okay, some info you can get it from your textbook. Based on the kinetic theory of the matter. Kinetic theory matter means the molecule particle that keep moving. We call kinetic theory. The higher the average kinetic energy of the molecule, the higher the temperature of the object. So when you see the molecule that move faster, so that means the temperature increasing lah. But the latent heat absorbed during the melting and boiling does not increase average kinetic energy. Okay, for you changes the phrase. Example melting, example for boiling. Okay, they do not changes any kinetic energy. So means what? No changes temperature. So if I say temperature constant means you cannot bring the kinetic energy go in. Okay, that's a not related already. Okay, so when you just explain, so you just ignore kinetic energy of the molecule because the temperature constant. Okay, so we continue to the next part. Okay, you can see the one of the diagram. There's a 0 degree Celsius 1 kg ice. Then after that, constant temperature, they melt. They melt. So become 1 kilogram of the water, but the temperature still 0. So this one citation, we call it as a changes the phrase without changes temperature. Okay, so from here we go to explain these citations. Okay, we call it specific latent heat of fusions. Okay, remember, I are the LF. Okay, definition for specific latent heat of fusions. Okay, every part got definitions. Okay, you just add what they go to absorb, what they go to release. Okay, quantity of the heat, there's a Q, that is absorbed during melting. Okay, if you melt, then you just say absorb or quantity of the heat released during freezing. Okay, during the freezing, then help me to add mass of 1 kg substance. Okay, 1 kg substance. Then the last one, important, you need to write without any change in temperature. This one important. So you not only mention about what they absorb, what they release. The last one, you need to say no changes temperature. Okay, specific latent heat of fusion for the ice normally is a 336,000 joule per kilograms. Okay, the next one should be the boiling. Specific latent heat of verbalizations. Okay, the explanation almost the same. Just you change the phrase. Just now is melting and freezing. Now is what? Now is a boiling and condensations. So from here we just write quantity of the heat, there's a Q, absorbed during boiling. Or you say the heat released during condensation of 1 kg mass of the substance without any change in temperature. Okay, so this one is a two definition for the fusion and also variabilizations. So the specific latent heat of variabilization you see too high, more than just now the latent heat of fusion. There's a 2.26 times 10 power of 6. Okay, so this one is the specific latent heat. Okay, now we're going to see the heating curve. Okay, heating curve. Okay, heating curve, we need to see about the, just like the staircase lah. Okay, they keep upping, go up until become the gas. Okay, now we go through the one part by one part. Okay, first round, you can see the bottom one, the P to Q. Okay, P to Q, you can see the staircase is up, is it? Okay, staircase up, what's the meaning? Temperature. So P to Q, the temperature got increased. When the temperature got increased, so this part we cannot say there's a latent heat. There's a not related with the latent heat. If I say they're not related with the latent heat, means here PQ, no changes phrase because there's not latent heat. So what they change? They change temperature. So when they just change temperature, we just say there's a specific heat capacity. Okay, what we learned before, Q equal MC theta. Okay, from this part, what they want to explain for you. Okay, I go to Zoom. Okay, PQ is a solid. Okay, still solid. Because they never change the phrase. There's a heated until melting point. So heat is absorbed, temperature increases, kinetic energy of the molecule increase. Okay, for the part PQ. Okay, now you see from the P until the Q. Okay, Q, we got specific name for the Q. We call it as a melting point. Means when they just achieve to the Q, they start to melt. Okay, they start to melt. So you can see Q to R. Q to R, can you see there's a flat? Flat means no changes temperature. No changes temperature means this situation, latent heat is top part. Okay, latent heat is top part. So we take this one formula should be Q equal ML. Okay, Q equal ML. So that means they start to change the phase. So this situation, you can find the matter. We got two states. There's a solid and liquid. There's a mix together. So that means Q, they start to melt, is it? Solid, now they're starting to change, become the liquid. So when they just start to melt, they got mixtures. A little bit solid, a little bit liquid. So achieve until R means what? When they just until the R means all become liquid already. All the ice already melt, become the liquid in the R. So that means R ending of melting point, finish already all the melting. So you see the temperature keep increasing. After melt, R to S increase already. So increase means specific heat capacity. So from here we see the explanation for RS. R to S means liquid is heated until boiling point. Now you start to heat. After melt, you start to heat. So heat absorb again. Then after that, the temperature keep increasing, kinetic energy molecule increasing for the RS. So for this part RS, you can find it, the start all is a liquid. No more solid, all liquid already. So when they just heat until when? Until S. What's the S? Boiling point. Okay, means all the water that's finished to boil already, they want to ready to change the phase in the point S. So in the point S means S to T. Can you see the flat again? Flat again means they want to change the phase. Okay, the temperature keep constant, they want to change the phase. So this part we call it latent heat of variabilizations. So from here, there's a mixtures, liquid and also gas. Okay, because they start to boil. When they start to boil, they mix a bit liquid and gas. Until T, what happened? All the liquid, all changes become gas already. Okay, now they keep increasing the temperature. Okay, but now the situation already finished. There's a gas only. Okay, we don't have other method. So from here, T to S, now the gas heated. You continue to heat. So the heat absorbed, temperature increase, kinetic energy also increase. So for the last last part, T to U, there's still specific heat capacity because the temperature increasing. What's the phrase? The phrase is a gas. Okay, remember, every part we also need to explain. You need to understand which one part we need to using what formula. Okay, increased temperature, specific heat capacity, Q equal MC theta. When it's just flat temperature constant, there's a specific latent heat. Okay, Q equal ML. Okay, understand that this one heating curve. Okay, so the point for you, this one is the specific heat capacity when the temperature increasing. So you see the solid, there's a closer. Okay, under this part, they become liquid already. So you can see the molecule further. And the last part, they become gas. The molecule is further each other. Okay, randomly to move it. Okay, then this one also is a heating curve. We just explained about the part for flat. No changes temperature. Okay, first one is a QR. QR, we call it as a melting. Okay, melting part for QR. Solid to liquid. So Q stand for solid start to melt. QR means solid is melting. On the way is melting, continuous stand. Okay, until R, what happened? Whole solid has melt. Okay, then we go to S to T. Okay, S to T, we call it as a boiling. Boiling is a ST. Liquid go to the gas. What's the S? S is a liquid they want to start to boil. Okay, liquid start to boil. Okay, during the ST, they call it liquid is boiling, continuous boiling. Okay, until the T means what? The whole liquid already boiled. Okay, so this one is how we go to explain the part when the temperature is constant. Okay, now again for the heating curve, we need to explain about the point, the melting and boiling. Okay, T1 we call it as a melting point. Okay, so T2 we call it as a boiling point. Okay, for the Q to R, the flat one, and also S to T, temperature remain constant. Okay, no temperature changes. Okay, now it's a reason why no temperature changes. Just now we explained so many things already. We say latent heat is a constant. Why? Why temperature constant? Okay, here is the answer. Because the heat supply, you still supply the heat, is it? To the object is used to what? To overcome the forces for the attraction. So to hold the particle together. So that means you provide the heat, they never go to increase the temperature. They go to what? They go to break the bond between the molecule. Because you want to change the phase, from the solid, you want to change liquid, is it? So you want to break the bond. Okay, when you break the bond, you need energy. So this one energy come from where? Come from the heat energy. Okay, you provide the heat, is it? So that's why the heat already used to overcome, to breaking the forces. So that means they cannot use again for increased temperature. So this one question always will ask. Why the temperature keep constant during the specific latent heat? So you need to answer. Okay, to use to overcome the forces of the attraction that hold the particle together. Okay, so this one should be the answer. Okay, C, heat absorbed during the QR. QR is called latent heat of fusions. Okay, heat absorbed during the ST, we call it latent heat of vaporizations. Okay, clear is it about the heating curve? Okay, if you're clear about the heating curve, now I need to go to opposite. There's a cooling curve. Okay, cooling curve means you see the staircase come down. Okay, the explanation almost the same. So the first part, they're talking about PQ. PQ is dropping. So now the gas is cooled to boiling point. Okay, I go to zoom. PQ is gas cool down to the boiling point. So from here, heat is released. Just now it's absorbed. Now I want to release. Temperature drop, decreases. Kinetic energy of the molecule also decreases. So from P to Q, you can see the temperature drop. temperature drop is related with the specific heat capacity. Okay, P will drop until the Q. Q is a boiling point. Okay, from this part, we didn't call this a boiling point. We call it as a condensation point because you start to condensation, is it? So Q to R, you can see the temperature already flat. Temperature flat means latent heat is took place. Latent heat took place means they changes the phase. From the gas, they want to condensation become the liquid. Okay, so this part is a latent heat of vaporization released. Heat released. Okay, how about the RS? RS means the situation temperature drop again. Okay, temperature drop again, there's a RS. Liquid cool to freezing point. Okay, liquid now start to cooling to freezing point. Heat released, temperature decreases, kinetic energy decreases. So that means this one also is MC data. Okay, because it changes temperature. So they changes until where? Until the freezing point. Because they start to freeze. Okay, R to S, the freeze only liquid. They don't have any mixtures. Okay, until the S, okay, they start to freeze. Before they start to freeze, sure, it's a mixtures lah. Liquid and solid, they mix together. For this part, we call it latent heat of fusion. Okay, but there's a released. Okay, from the T, that means they already full. Released, change the phase already. TU all become solid, become ice already. Heat released, temperature released, kinetic energy released. So T to U, they keep dropping the temperature lah. So that means already is a ice. Okay, already is a ice. Then you just cooling, there's still ice lah, solid already. So that one should be the maximum, no more already. Okay, so you find it, the diagram for the molecule that becomes solid again. So the molecule become closer. Okay, so this one is a just reverse with the heating curve. So this one we call it as a cooling curve. Okay, remember, don't mention boiling point. We just mentioned there's a condensation point. Another one is a freezing point. Okay, so this one cooling curve, we go to one by one for the flat one. Okay, flat one, Q to R, we call it as a condensation. Condensations. Okay, gas become liquid. So this one, gas start to condense. At the Q, they start to condense. QR means condensing. Okay, continuous. Between there, they're doing the process. Okay, until the R, what happened? All the gas already condensed. Okay, now we go to ST. ST is a freezing part, is it? So from here, we call it as a freezing. Liquid becomes solid. Okay, S means what? Starting. Liquid start to freeze. ST, freezing. Okay, continuous freezing. ST means what? Okay, S is start to freeze. ST is continuous. T means already finished or already freeze. Okay, so you find it, they become a process for the condensation and also freezing. Okay, so this one is what we want to inform you lah. What is the difference between the condensation and also freezing? Heating curve, cooling curve, then you must very clear for every part. Okay, then we go through to the explanation for the point. Just now we mentioned about the point. So first one, T1, we call it as a condensation point. So condensation point, don't say there's a boiling. Okay, T2, we call it as a freezing point. Okay, T3, we just mentioned there's a room temperature. They already flat. Why UV constant 1? UV means what? What means the UV, Celiang? Okay, what means a UV? So you answer me, what's a UV? Okay, so you can see UV room temperature, because room temperature already is a maximum. Okay, they drop until the 0 finish lah. That one we call UV. Okay, so just like the room temperature, no more already. So they just drop until the solid, then no more. Okay, that one finish. Okay, from the graph, I know. From the graph, solid already. Okay. That means they're already in a freeze. The temperature already is constant there. So they never change anything. Okay, so from here, we just mentioned T3 is a room temperature. During QRST, the temperature remain unchanged. This is because the heat energy released. Okay, just now is the temperature never change because they use the heat to break the bond, is it? Now cooling is what? Cooling is they release the energy. The temperature never drop. Why? Because they release the energy, go to join back the bone. Just now is break. Now they want to join back. Join back, you also need energy, is it? So you need to release the energy, go to join back. So that's why the energy, the temperature never drop. Okay, the temperature never drop because you want to join back. You also need to release the energy. So from here, they say because the heat energy released to the surrounding during the formation of the bond. So heat energy release, QR, we call it latent heat of vaporization. ST, we got it as a latent heat of fusions. Okay, so remember, no temperature changes. One is break down the bond. Another one is joining back, formation back for the bond. So that's why the temperature keep constant. Okay, we got some activity here. The student can be answered lah. Okay, we want to compare and also discuss about the specific latent heat. Okay, first one, we got latent heat fusion, ice, and also the wax. Okay, another one is a vaporization of the water and also the oil. Okay, both also liquid, both also solid. You see what's the difference? Okay, let's see the table. Wax and also the ice, both also liquid. Okay, but the latent heat is different. You see the wax is 2 times 10 power of 5. How about the ice? Ice is more a little bit from the wax. So compare the specific latent heat of the fusion. Sure, the ice is higher than the wax. Like you say, we see the table. So we just say ice is bigger than the wax. Okay, state the difference between the ice and wax in terms of the strength bond to be between the molecule. Which one the strength becomes stronger, ice or wax? Okay, when you want to change the phrase, you tell me which one strength is stronger. That means you need to longer time to break it. Okay, so ice or wax? Okay, how to see the specific latent heat? Actually, what's the meaning? Okay, specific latent heat means the heat you require to change the 1 kg of the substance from the solid become liquid. So which one is harder a bit? Wax or ice is harder. So from here, sure we know, sure is a ice, is it? Celian answer already, that's a ice. Sure one. Why? Because the specific higher what? Specific higher means I need more heat to overcome the bond, is it? So from here, the answer is the arrangement between the ice molecule are more closer. Okay, after that, strength of the bond between the ice molecule is stronger. Okay, we know when the latent heat is higher means they are more closer. More closer means the strength, the pulling the bond is stronger. So you need more heat to overcome the strength. Okay, so we continue to the next question. Okay, now I want to compare the latent heat of vaporizations, water and also the oil. Okay, now it's a table. We got 3 things: water, turpentine oil, and also petrol. 3 also is a liquid. Okay, latent heat is a difference. See, you see the water 22.6. Okay, then the oil is 2.51, petrol 3.49. So the highest sure is the water lah. The lowest is the oil. So the first question, they want you to compare the latent heat, water and petrol. Sure, water is a higher. Okay, so water more than the petrol. Okay, B, can you state the difference between the water and petrol? Okay, water and petrol, in terms the strength of the bond between the molecule and distance separations. Strength of the bond, sure the water is stronger. Okay, because you see the specific latent heat. Okay, number 2, distance separation. Distance separation for the water sure closer. Okay, because the latent heat also higher. When it just closer, that means you harder to break the bond. So from here we find it, distance of the separation between the molecule in the water are closer. So the strength of the bond between the water molecule are stronger. So understand or not about the specific latent heat? When you see the number is bigger, means there's a more energy need to require to overcome the bond. You need to break the bond. Means the bond is very stronger. Okay? Okay, now we're going to see the specific latent heat of fusions. There's a 3.34 times 10 power of 5. Specific latent heat of weabilizations for the water, 2.26. Why big difference? Can you see this one power of 5? This one power of 6. Why? This one is one of the question they also will ask. Why the value is different? Both also is the same material. Is it water freeze, they become ice. Ice melt, become water. It's the same thing, is it? So why they got big difference of the latent heat? Okay, now we're going to see the answer. In latent heat of fusions, the energy is given in the molecule in the solid so that can be moved freely in the liquid. Okay, the heat using what? Used to break the bond from solid to liquid. Okay, so now you can see the weabilization. What's the difference? In latent heat or weabilization, large amount of the energy is needed to separate the liquid molecule become gas. Okay, this one is a normal. You want it the liquid become gas. And they got one more process. The one more process is they want to overcome atmospheric pressure. Because outside we got A, is it? A also is a gas. So I need to overcome atmospheric pressure. Solid to liquid, different phase. Gas is another phase. So when you solid go to liquid, you no need to overcome atmospheric because there's a different phase now. We no need to overcome about that. But from the liquid, you want to become gas. There's a gas and atmospheric. The oxygen, all the things should be the same phase. It all is a gas. So you need to overcome one more part. There's an atmospheric pressure. So that's why you can find it. The reading is bigger. Okay. So conclusion from the form easy, separate, hard. They will take bigger. They will harder to separate lah. Maybe the time taken is longer. Okay. Time taken is longer. So you can see the flat. Just now I show you the graph, is it? For the fusion, the flat should be short. Okay, for the weabilization, the flat part, temperature constant, should be far away because it take longer time. Okay, because the horizontal, the x-axis is the time taken, is it? So the time taken should be longer. Okay, so this one is a why fusion and weabilization is a difference. Okay, because you need to overcome two things. One is a phase, another one is the atmospheric pressure. So they will take longer time a bit. Okay, so this one is the differences. Okay, so from here I want to introduce what formula, what we learned. First one, when the heat added or you say remove, change the temperature, we call it as a Q equal MC data. Okay, Q equal MC data. Okay, when the heat add or remove, change the phase on the temperature on the object without changes temperature, we call it Q equal ML. Okay, we apply this formula. Okay, if the heat is supplied by the electric heater, you must see this word heater. When I just say heater, that means we need to using power. Okay, because they apply electricity, is it? So we need to using the power. Okay, using the power. So they must relate it with the time taken go to heat the object. So they change the phase of the substance. So Q equal ML, we can be write as a PT equal ML. Okay, remember when they're just using the heater, we just change the Q become PT. Okay, power multiply the time taken go to heating. Okay, so we continue to the next part. Okay, we left how many? 15 minutes. Okay, we see the question. Okay, you prepare to answer me. Calculator, please. Okay, so we start now. Okay, if the 2 kg of the ice melt when 452,000 joule of the heat energy is supplied to it, what's the specific latent heat? Okay, straightforward question. So we just show you. Okay, straightforward, I just show you. Because L equal Q over M, 452,000 joule over 2 kg. So the final answer is a 226,000 joule per kilogram. So this one is a latent heat. Okay, this one just simple question. Later I got more about harder ones, so you need to answer me. Okay, example 2. Okay, you see an ice cube the tray in a refrigerator. They hold 0.4 kilogram water in 0 degrees Celsius. Okay, how much heat must the freezer remove from the water to mix it as an ice cube? Also 0 degrees Celsius. Means what? Temperature no changes. Temperature no changes, but they still go provide the heat. Okay, but we don't know the heat how many lah. Then they give you latent heat. That's a 3.36 times 10 power of 5. Okay, now you need to find for me what is the Q. Okay, what is the Q? So from here, the student can be start to find for me what is the Q. Okay, so from here, I just wait your answer. Okay, we just left on around 17 minutes. Okay, so the student, you can answer me. Okay, but slow a bit because here got a little bit line problem. Okay, Celian got answer already. 1.344 times 10 power of 5. Okay, we check it. So we're using this formula, Q equal ml, 0.4. Okay, this one is a L. So final answer, 1.344 times 10 power of 5 joule. Yes, correct. Exactly correct. Okay, we go through to the number 3. Okay, immersion heater. Remind you heater. Heater must using PT. Supply the heat of the rate 50 joule per second. You must see, be careful this word. 50 joule per second, not energy. Because there's an energy over time. 50 means power. 50 watt. You can say 50 watt, but the question they want to make you don't understand. So they just joule per Celsius per second. So suppose this one is a power. To an insulator vessel containing the liquid. Now the liquid is brought to its boiling point and keep boiling for 2 minutes. Can you see the question? Catch you again. Minutes. During which time the mass of the liquid was 40 gram. Gram again. So what is the value for the specific latent heat of vaporization? Many info. What we need to do? Show the info. Okay, write out all the info. Power, 50. Time taken how long? 2 minutes. 2 minute change becomes second. 120 second. Okay, mass convert. 40 gram convert to kg. So there's a 0.04 kg. Last, the question want to find L. Okay, can you find for me what is the L? Okay, so I just read the answer from the student. What's the answer for the L? Okay, this one you need to using PT. PT equal ml. So you'll find what is the L. So remember when the exam, be careful to see the unit because you need to convert. Okay. So the student can answer me or not? Is it still Celiang again? Okay, we just wait. Oh, memang it's Celiang again. Is it all go to test? Sejarah test not yet finished. Okay. So from here, we go to check the answer. 1.5 times 10 power of 5. Okay, we go to check. So this one should be the formula we need to use. Okay, 50 multiply 120 over the mass 0.04 kg So the answer is 1.5 times 10 power of 5 joule per kilograms. Okay, so that one is a latent heat. Okay, correct. So we continue for the example 4. Okay, example 4. So the example 4, you see the question. Water is boiling. Water is boiling. Electric kettle, they give you the power. Okay, power. How long does it take for 0.12 kg of the water to boil? Then they give you the L. So that means the question, they want to find the time taken. So we write the info. Power provided. Mass 0.12. Latent heat also got, but we don't know the time taken. Okay, so the student, please prepare to press your calculator to give me the answer for the time taken to boil the water. Okay, so from here again, the student, you can just apply the formula for PT because this one already got a power. Time taken we do know, then the ML. Then you find the T from this question. Okay, we're going to check. Okay, answer from Celia again, 75.33 seconds. Okay, now we go to check. Okay, PT equal ML. So from here, T equal ML over the P. So the final answer, we just put in all the info we go to put in. So 75.33 seconds. Okay, that's correct. So we continue, see got question or not. Okay, number 5 also got one more question. Okay, they show you the graph. Okay, 0.5 kg of the solid block is heated by the 100-watt heater. Heater again. The graph they show about the temperature varies the time. Calculate the specific latent heat of the fusion of the solid. They want to find the L. So this one situation is the electrical energy convert to heat energy lah. Okay, we just write the info first. Okay, the info power is 100. Then the mass for the object is 0.5 kg. Okay, latent heat, don't know. The question never provide latent heat. Time taken, we need to refer the graph. Okay, you see the time taken. Which part is a latent heat? Okay, so this one is my question. Before I do the calculation, you tell me which part is a latent heat. Is it 20 to 80 or 80 degrees Celsius flat? Which one? Can you tell me the time taken? Time taken for the latent heat from 0 to 300 or 300 go to the 1050. Okay, I want to take the latent heat, but I need to know, I need to understand what's the latent heat from the graph. So I need to choose. So from here, the student can tell me which part is the latent heat I need to take. Okay, the 80 flat. Yeah, correct. Flat. Remember, latent heat must be flat. Okay, the staircase up, they want not latent heat. So we want to take about the flat one. So from here, I need to count the time. Okay, from here, I can count about the time. So the time is 1050 as a half here. Here is a 1100, is it? So this one is a 1050 lah. Minus 300. Okay, minus 300. Yeah, correct. Siliang, there's a 750 seconds. So this one should be the another info I need to know. Okay, if not, I cannot do calculations. So from here, I show again my new info. I get it, 750 seconds. So now I can apply my formula to find what is the latent heat. Okay, so now is the last. You need to answer me. What is the latent heat for the part you say flat? Okay, for the part you say flat. Okay, so from here we check from the student what's the answer for the last. Okay, the last part we find it, there's a 750 seconds, is it? So we just see what's the answer for this part. Okay, we're still using PT, because it's a heater. They're using the heater. Okay, we left 5 minutes more. I think this one should be the last one. Okay, should be the last one. For the student, you just finish the sejarah, please, sir. you need to do the Google form because you need to handle for today attendance. So, okay, yeah, Siliang, Sabrina. Oh, Sabrina, and long time didn't see you already. Okay, so from here, the answer is, okay, we're using formula PT over the M. So the answer is 1.5 times 10 power of 5. Okay, so this one's the answer for example 5. Okay, the example finished. So today what you need to do for the 4 science 2 and 4 science 3, please go to Google Classroom. I got upload one of the PBD 4.3. You must do a PBD. So this one is a specific latent heat. Some of the question you need to do the calculations. After finish, please turn it. Okay, must turn in. If not, I cannot see your name. I cannot give you the marks for the PBD. So another one should be the Google form. Today, the Google form for your attendance, they got code. Okay, Siliang, help me to type the code. The code is a 288. 288 number. 288, then hashtag 2021. Okay, repeat. 288 hashtag 2021. Okay, you just type there. Then the student, you please you go to see what Silang typing. Okay, 288. Okay, hashtag. Not yet finished. Silang 288 hashtag 2021. Okay, you just write 288. After that, you need to hashtag then 2021. Yeah, correct. Okay, so that one is what you need to do. Okay, what you need to do. So this one is the code. Celia already typed there. 288 hashtag 2021. Okay, for today, the lesson code. Okay, for the Google form lah. The round of 5 of the question you need to apply lah for today about the specific latent heat. Okay, so our lesson just until here. Just thank you for your watching. Okay, all this talking is Siliang. Okay, do know the other student go where already. Okay, so our lesson just until here lah. Every student just thank you and also bye for your watching. Okay, thank you Sabrina. Bye bye.